Thank you for joining us on the Wood World podcast today. Today I've got a special guest for you. His name is Miles. I just feel like Miles has a really cool story personally and is working on great technology that's going to benefit the wood world and the people in it, as well as much beyond that too. So with that, Miles, could you please give a little introduction of who you are and what do you do?
Yeah, my name is Miles Murray. I'm the co-founder and CEO of a company called LOCOAL, and we specialize in next generation wood and other organic material recycling systems. And the name of our technology is the Rainmaker, which is an intelligent mobile biomass and bioenergy conversion product that yields biochar, carbon capture through biochar, and clean energy through synthesized gas.
Miles, that's a mouthful. Thank you. Thank you for so much for coming on to the podcast. I'd love to start with Miles. You and I talked a little bit ahead of time, but for our audience that doesn't know, um, I'd love to have you share and tell us a little bit about your personal story. How did you get to doing what you're doing now? You've got a wild story. Can you walk us through it, please?
Yeah, I guess you could say that. Well, the first and foremost is that I was born and raised in the world of wood. My grandfather passed on to us eight generations of tree farming in northern Louisiana. And so, all growing up in the summertime, I would, get in my parents' Suburban, the old boxy one, and we would drive all the way to northern Louisiana for a month. And every year, we would do a partial harvest of the farm. And one of the things that I always noticed is A, it took a very long time to grow these trees, and B, it was a violent and quick culling of them in the same process. And we would leave a lot of wood waste behind while we were creating timber. And that always stuck with me, the amount of waste that would be created in the production of lumber.
Hmm. Are you specifically talking about like in the forest when there's limbs and
Yeah, there's the trimming, which you've got. For those that know forestry, you'll know that there's the hedging and the trimming and the culling of the trees that aren't going to produce the producer's size crop that we're looking for. But also in the process of making refined woods and actual lumber, there's just a lot of clippings and shavings. So not only do you leave a pile behind at the initial harvest, but once you've put it through milling, you leave a lot of sawdust and trimmings behind in that process. And we would just pile it all up and burn it. And I always thought to myself, I'd be curious if there was something else we could do with that.
sure. Touch a little bit more about so as you were growing up, you say, and then what happens? How do you get into the working world, your career?
Yeah, so I didn't pursue tree farming professionally. That was a family business that I kept over in Louisiana. I grew up in Central Texas, and I was in high school when 9/11 happened, and I just felt the call to go serve my country. So I was fortunate enough to get a chance to go to West Point, which is the also known as the United States Military Academy, Army Navy football. That school. Spent 4 years there. My main interest was environmental engineering because they don't have ag like they do at Texas A&M. So it was the closest I could get to it. But it was also of interest of mine on why do people do what they do? And so when I left the academy and I went to the military, I had a chance to serve in a remote outpost in southern Iraq where there really wasn't a lot of combat, but there was a heck of a lot of engineering that was lacking. They did not have working electricity, working water. Their hospitals were only partially filled because they just didn't have the infrastructure. And in all my time there, I just kept on seeing a similar thing where now I'm burning piles of trash that included rubbers and plastics and wood, all while trying to help build parts of this country up. And their solution, too, was just burn it all. And so in my time there, as an interesting part of our time there is that while we were trying to help the local politicians and leaders, community leaders build, there was a whole force of people that didn't want to see that happen. And they had militias and they had, a lot of times at the time we used to call them terrorists, but like what I was seeing locally in my region were a lot of resistance to change and improvement. And then there was what came on the heels of that were a few, Iranian state sponsored attacks on us. And it just, in the moment, you're kind of focused on the combat. But over time and reflection, I really started to kind of look at it through the lens of, change is difficult and progress is a threat to somebody. And so, in light of all that, I just really started working professionally after I left the military towards technical solutions that created more autonomy and clean energy, waste diversion systems, and circular economies. Because I just felt wholly that if you can build a prosperous foundation of your supply chain and your management of natural resources and the waste tailings, then you just have a lot more opportunity to succeed. And coming from Texas, we have that whole "don't mess with Texas" aspect of our culture, but really it was like don't mess with our natural ecosystems, don't mess with our rivers and our white-tailed deer and our dove. We like the natural conservation aspect, but we're also very energy forward. So sort of took the best of that aspect and reflected on kind of where we see the world moving towards a desire for circularity.
I love it. So, at what point do you get the idea, or how do you start this company that you now run? You're calling it LOCOAL.
LOCAL. So LOCAL is not my name. That's my co-founder's name. So like behind you, you can see this axe right here.
Yes.
And what that axe represents is the very first tool that the local, at the time, charcoal company used to create carbon out of wood waste. And my co founder, a gentleman named Matthew Peterson, who goes by Petey, I met him at grad school. I had wanted to go find a co-founder and build a technology company, and I found a co-founder that was hair down to his middle of his back. His fingernails were black with this dark charcoal looking stain, and he had a cut off shirt and outside work pants on the first night of grad school where everybody else is wearing a suit. And I just said, who is this character of a human being? But the reason why he was dressed that way is that he faces what a lot of entrepreneurs face, especially when they're alone. And he had to make a delivery right before the meeting. Otherwise, he doesn't have money to fund the next week of business. And so instead of spending the time to get dressed into his clothes, he went and made his delivery and then literally drove all the way up to right to the campus and ran up to the top of the building to meet everybody. And what he inspired in me was this idea that there's a lot of, waste in the pecan space, and that led to pallets and other sort of manufacturing processes of the food system or the supply chain, where then I really started seeing how much waste was being aggregated. And I told him I could build him a better tool than an axe. And so we built a big automated bioenergy system.
Okay, so that big bioenergy system you're talking about, that's the focus of your business today. Is that right?
Yeah. So we wanted to be able, so our mission was to use the readily available wasted wood materials, rubber and plastics, for the purpose of providing a decentralized sort of alternative to landfills. So intercepting landfilling with materials that we knew we could convert into carbon, like capture the carbon and produce clean energy. And so that was sort of like, that's true north, was, end landfilling and create a circular economy out of it, which is not new entirely. People have been trying to figure out a way to do waste reclamation for some time. But what we didn't see was that there was a scalable, durable carbon capture method that could really achieve some of the grander goals that are being set out by governments and large corporations about how many tons of CO2 they want to sequester. And there's a lot of different things that people use: forests, direct air capture, accelerated weathering. But none of that really had a lot of great utility. We wanted to capture carbon in a way that it has utility. So Rainmaker, that we call it, is it's a modular skidded system on a 53-foot skid. It's 8 feet wide and 13 feet tall, and I built it that way because going back to my time in the military, we were decentralized in all of our operations, and what we had no short of was containers and radios. And so I'm used to running a large scale operation where there's many small teams peppered all over a large geographic area. And I knew that moving logistically machinery through containerization or skidded intermodal containers was a good move. So we made a compact, highly, highly automated and very advanced from a pyrolysis technology standpoint system that really precisely captures the most pure carbon out of these systems by heating it up to a certain level, and then sort of the carbon is all that's remained and everything else turns into this thick kind of combustible gas. And then we scrub that gas inside the system to where it's clean enough to operate a generator and then power itself. So it becomes a self-powering, relocatable, fully automated biochar production system that also nets about 1 megawatt of excess energy.
Whoa. Okay. So you just give us a little glimpse of the black box that your system is. Can you give me a little bit of a higher level understanding before we continue down the path of understanding how it works? What is the input? What is the output? You kind of just touched on it just now briefly,
Yeah.
but if you were to say it simply, what's the inputs? What's the outputs?
Between 2 and 4 tons of sawdust per hour turns into a half to 1 ton of carbon and 1 megawatt or so of energy excess. And so what goes in is sawdust and what comes out is carbon and gas. And then there's also some bioliquids and bio-oils that are extracted in the process too. And so it's separating wood into 3 different phases. You've got all your sulfurs, your SOx and NOx that get put into a filtration tank, and then your methane and your other hydrocarbons that can burn get moved into a gas, and your carbon remains in solid state. And so now, instead of it being an unusable product that can decompose and rot, and now it can be used for a lot of different applications than just what the wood industry normally services.
Miles, and I guess the other question is, it's where in the world can people deploy this system, or where have you
Yeah.
seen it already be deployed?
So most of our customers are people that produce, a lot of sawdust or a lot of wood shavings or a lot of rubber clippings from tire manufacturing. And so where we want to strategically position it is one of 2 places. The first place is right co-located at a manufacturer's facility. They're trucking 18 wheelers a day away, $1,000 plus per load, with all in costs, and that's in the inner cities. And then, those trucks are spending time in traffic, getting to the landfill, dumping it, and coming back. And regulations don't allow them to burn it, and real estate pricing doesn't allow them to store it. So they need a place to get it off. We could replace that 18 wheeler a day with our system, bag all the carbon that comes out of it, and send it to retail shelves. Whereas the gas can be turned into electricity that can then power a generator that also powers part of their facility. So what is right now a cost and a waste becomes a profit and a resource that you can consume on site. The other side of it would be where there's aggregation points. Sometimes, the forestry department doesn't want us to stick a rainmaker in the middle of the forest for obvious reasons. But mainly because they're scraping a lot of the debris. The forestry private companies are doing their slash and they're harvesting, and they're going to be piling up all their slash in certain spots. And so wherever it's being aggregated today as a sufficient enough volume would be a good place to co-locate. Um, you have dumpster roll-off companies that want to do this. They'll separate the wood from all the non feedstock items, and then that is a major lift for them. So it's where the end of the manufacturing process or the beginning of it, and that's where you kind of like trees cut down, trees turned into small boards with a lot of sawdust.
Hmm. Well, and there's uses for that sawdust. So, like when I go around sawmills, I hear different companies treat the what you would call residuals into, different parts of the residuals go to different places, and so I guess this is another opportunity for them to make another value. Uh,
Yeah, we know, and there's some uses that I think are going to continue, but there's a lot of low yield seasonal type of uses. There's only so much compost that can be made and sold, right? There's only so much wood that can go into mulch. I think when we looked at the latest statistic, only 5% of residuals can go into mulch before mulch is so saturated that they might as well give it away. And so, where there is some alternative places to take them, and again, some people listening to this have probably found some phenomenal uses of it. But we found is it's either a low cost, it's either a cost or at best a no cost, um, you know, end of life cycle material for the manufacturer. What we want to do is we want to turn that into a profit center on site.
Understood. So, besides sawmills directly, you mentioned there's other types of input that the Rainmaker can take in. Could you name other inputs that you've seen? You've mentioned rubber trimmings. What else besides wood goes into the machine or can be
Yeah,
taken
I
as?
mean, so biomass at larger scale here, it has to do with like anaerobic digest sludge, wood fiber sludge. Um, the base materials that are inside of there are the ones that we're targeting, fixed carbon, and there's still a lot of hydrocarbon chains that are built into that structure. And so you've got rubber, you got pelletized sawdust, you've got regular wood chips, you have certain plastics that are good for pyrolysis that can, you can yield a good energy stream out of that. You don't get much carbon out of it, but you can get some liquid carbon black six, and so we primarily focus on wood because it's what we've chosen to kind of spearhead the technology on. And for those that are on the product development side, it's designed to be extendable across any feedstock that is responsive to thermochemical decomposition, which is basically we heat it up to a certain point and it changes form and factor. We can't put metal in there. We're not we're not smelting metal, and we're not going to put inorganic such as dirt or rocks or anything that really doesn't respond to um, to chemical combustion or pre-combustion.
Totally. What have you seen in terms of you've already deployed some of these systems, I believe, right? You've told me some are out there
Well,
in the field.
yeah, we've been in a so we've launched since 2019, and as sort of a next generation technology company, we've been mainly in research and development. The U.S. Air Force has been a major benefactor to us in R&D, effectively discussing how we've got a world where there is going to be a lot of infrastructure disruption that we're anticipating on the horizon. This was in 2020, so like we're kind of realizing it now with the wars that are all over the planet right now. and that the drive for sustainable, like rapidly deployable renewable energy systems that do not require an external fuel source to be able to provide power. So that was the thesis. They've been funding us. They funded us 3 rounds over a little over $3 million in R&D, and we've taken some investors in. And so we have built our third generation of the technology in a laboratory, and our final commercial version is in final manufacturing and assembly, and will be deployed in January um, as our major product release.
I love it. I love it. What do you anticipate you touched on it just now in terms of infrastructure disruption. Can you share any more about what you anticipate and how does the technology help with that disruption?
So, one of the things about technology is that it moves alarmingly fast every year. But for parts of the world and economies that have not had the same adoption rate of technology, we have to do some skipping and bounding for them to be modernized. And so you look down all throughout the Caribbean, and there's a ton of shells, coconut shells, as well as other types of wood that is kind of in abundance, but they have a lot of energy resiliency problems. So we're not even talking about just war conflict. We're just talking about keeping societies up with the speed at which more advanced societies are advancing at an alarmingly fast pace. And so internationally, we've gotten interest from Australia, from Europe, from the Caribbean, South America, and Asia as of recently. So I think Africa and the Middle East are kind of our next areas of, is there an interest here? But what we've really learned from a lot of the leaders of those countries, and we've had a chance to talk to a number of their delegations that are looking for the advanced renewables engineering teams, is that they want an economy where they can produce clean energy in areas that are too difficult to invest into infrastructure. And then when you look at areas where infrastructure is being disrupted, to allude to your question, you look at, like, you don't build yesterday's solution, because when yesterday's solution got destroyed, you have to build the next one. So we start looking at, how are we going to employ a data-driven type of grid infrastructure that has predictive analytics. We can harden areas. We know where there's going to be weather conflict, and we can build and harden, these infrastructure pieces to be more resilient. And resiliency is sort of that's the other buzzword around sustainability. It's a sustainable and resilient future. And resilient means environmental conflict, human conflict, and dilapidated legacy systems that must be, converted into modern systems. All these need to be built with a degree of resiliency and hardening, and not just a rapid build.
Here's something that's happened recently, right? We've seen hurricanes and storms come through. From my
Right.
understanding, all the biomass that gets generated in this practical instance, a hurricane comes through and there's a whole lot of trees and just biomass. Where does it go, and what could be a solution that you could say, well, here's another way to do it?
Yeah. So our lead client, that's taken our first deliveries, basically said, I'm having to turn down what I could see as potentially 10 years of feedstock that happened in a single storm, simply because we don't have the capacity to hold it this long. We don't have enough of your systems on the ground in the next year to convert it all. But if we could get 10 more systems on the ground in the next year, then we would be prepared to intercept a large quantity of hurricane generated biomass waste. And that could then return back to the community an energy source. Because at that scale, you're looking at 10 megawatts plus of power. You're a small power producer in Georgia at this point, And so, and that comes with its own challenges, to be honest with you. Like, our solutions run into roadblocks that are kind of unintended consequences of legacy systems. Like, how much energy can we pump into the grid? Well, depends on how overloaded the grid is, and how, the inability to relieve grid intensity on production side whenever there's demand side could wane. So you can't overproduce while people aren't using the lights. So it's one of those things where not only could we be a diversion of this waste, we could be a small power plant producer, and with battery technology and with localized microgridding as opposed to long transmission grid, we'd be able to get power up faster. It'd be more resilient because we could close up our machines and make them hurricane proof during the storm and then fire them back up within 24 hours and immediately start cranking a clean energy, even if long thermal transmission is down over long lines. So localized, resilient, renewable energy utilizing relatively readily available waste. And it wouldn't just be for that period of time. Like we're talking, these piles could burn all year until the next hurricane, you know.
And where does all that waste go today? Just the landfills? All the biomass?
Well, it depends on where you're at. I mean, when I was working in recovery response for Katrina, we were literally setting it on the median of the highways. And they were being sent off to aggregators that would just be paid under a service to grind them down into sawdust effectively, and then just kind of spread them wherever they could. But there's really no like advanced economy or process around this. I mean, there's every year there's enough service companies that their job is to pick it up, and then however they dispose of it can vary by company.
Yeah. Well, very interesting. There's a lot of I don't know if I want to call them theories, but you're talking about what's interesting is the long transmission, what caught my attention versus the localized production of energy. Seems like an interesting concept. How do you think that your technology scales?
So we work in a modular world. We're all connected. So even kids, they're connected on video games from different systems all over the planet, all kind of coordinated in the same gaming world, right? When you look at that in the physical world, we see, well, I would want to be able to have 10,000 Rainmaker systems globally, all being commanded, monitored from a central command center to make sure that they're optimized, the maintenance plans are right, their productivity rates are what they're supposed to be. And it's not just on like machine performance, but even like our customers, like, hey, you're not using this enough. What's going on? Are you all right? Can we help you get more feedstock? Are you having a problem with biochar sales? So as a company, we scale in three ways. First is we have an intelligent IoT connected system that can be placed anywhere in the grid, anywhere in the world, in a gridless world. Okay. And so physically, we can kind of spread everywhere. Locally, we're doing anywhere from 2 to 4 tons, depending on the density of the material per hour. And so if a location's producing 10 tons, well, we're going to do 3 to 4 systems, And so you can kind of modulate on site. So one site may have 4 systems, another site 2, another site may have 20. And so you've got kind of scalability in your step up manufacturing model on site. Then you have scalability through digital command and control. And then finally, like not only are we scaling just this technology, but what helps create that circle. So we have another system called the afterburn that will take all that synthesis gas and blend it with natural gas in order to power a much larger thermal generator system for even a greater energy load. We're going to be working on working with battery partners for battery long-term storage and grid balancing. So it's a high tech product driven kind of company right now. But as we step into this new sort of circular industry mindset, there's just a whole lot of linear concepts that are being challenged. And so it's not just me challenging them. The idea of a microgrid, one that's storm resilient, and the ability to spill off and store long-term energy instead of dumping it is real practical solutions to an ever-growing population.
Miles, you brought up a couple of interesting things. So there were domestic uses like the hurricane storm here, but I say here because I'm in Florida and there's multiple storms that ripped through this season. Um, but internationally, I'm sure you're hearing and seeing people coming to you with interesting concepts, or like you mentioned in those island type countries or states where they've have a lot of people that are energy dependent. They need the energy, but there isn't necessarily a clear way of how you get it over there or how you transmit it. Anyway, so maybe can you share a couple of other, like, what are the unlocks that technology that like yours will bring to nationally or internationally? Can you share some cool stories of practically how will people benefit from this technology that you've seen or heard so far?
Yeah, so you got a number of economies that are still what we would consider a wood and coal based economy, right? If you look at like energy economies, and so you take for instance down in the um, let's see. Now that you kind of asked me that question, let me think of a cool one. So
Sure.
now we'll take Mexico for instance. Mexico, right across the border, is shares a geographical similar terrain, but we're divided by the Rio Grande, right? And then that's our international dividing line between the two nations. But you've got a lot of farmers that are farming on both sides of that river doing pecan shells. And I use pecan shells because we the world consumes a ton of pecans. People don't realize it, but we do. 50% of the weight of the pecan is waste because it's the shell. And so it limits the economics of that particular industry, causing them to have to do roll ups and constantly kind of merging different things together. There's subsidy producers grants, a lot of things that have to make the farming industry, you know, profitable, and it's seasonal again based on subject to weather. What we figured out was if you take pecan shells and convert them into carbon and you infuse that into the orchard itself, not only do you reduce the watering requirement required in the first couple of years, but you also reduce a lot of the chemicals that are required to grow pecans because in the region in West Texas, both sides of the Rio, you've got a lot of depleted soils from generations of farming. And so a couple of years ago, we were out in West Texas, and I did a soil sample. I went 18 inches deep, and I found no microbial life. It wasn't soil; it was dead dirt. And so
Mm.
pumping humate and nitrogen and other types of fertilizers was just required just to get the plants up and going. And then the amount of water that's required for to grow this stuff is pretty substantial. Now there's strong water tables under the ground, but that takes pumps and that takes energy. And these are in far remote locations. So the demand charge and the cost of pumping that water is 10 times sometimes the rate of energy for a normal house that's located near transmission lines. And so just the economics that we could pull were kind of threefold. It was one, we can produce energy that you could use to pump your wells. Two, we could extract the carbon from the shell by diverting it from getting landfilled or burned, which you can't really burn anything in West Texas because of a forest fire concern or brush fire concern. And then three, the cost avoidance on the whole growing process. And this has been an ongoing study for several years, but what we've really figured out is when you can put our technology up to a large enough pecan shelling operation, you can become more profitable in that than the toll milling that is the cost to the farmer. So in theory, if economics work out well, we don't have to raise prices every year on farmers in order to keep shelling plants and packaging plants moving in the upward direction. And so as we look at cooperatives and however they do business with each other, this is a new tool to unlock, a better economy around this particular product. That's one case. I don't have a crystal ball, but when you look at how Ukraine is going to be rebuilt, we're not going to be putting in 1980s Soviet systems that they currently are destroying right now. or have been destroyed. What we're going to be building in is going to be largely renewable systems, but the cost of real estate and the upkeep of solar and the low density energy yield that per square foot sort of prohibits certain mechanisms. So we start looking at, well, can we make renewable energy more dense, your square footage, so that in the rebuild we're we're rebuilding these dense the power index, the density index of power, number of square feet required to produce this amount of energy becomes much better.
Wow. Well, Miles, what other things have I maybe not asked you about, but you're working on or you're excited about? I don't want to limit you, but if you have other
Well,
topics we haven't
I,
got
I think
into.
I think that from my position, I kind of sit in the peripheral of the wood industry as the wood waste. So I mean, there's a sector that I'm a part of, but I'm a part of sort of the aftermath of it. But you know, there's there's definitely been a rolling up a lot of everything kind of in the space when it comes to land, to sawmills, to paper mills, to forest management. There's just a lot of consolidation that's going on. And what I think, happens in a lot of that case is that, large corporations are doing kind of big initiatives that sometimes can be looked at as, oh, well, there's deforestation that's happening here, or there's, this type of, corporations owning large portions of our natural resources. But in all reality, these are also the companies that are sort of on the forefront of trying to find, good solutions. And as we look at it in the world of tomorrow, there's going to be a need for a lot of these corporations to decide on if they're going to be a leader in sustainability. And that's what I'm getting signaled by almost every sustainability department of all the large wood industries. And so we're fortunate enough to be in the right time and early enough in the adoption of this concept of circular economies to be able to have a very meaningful conversation about sustainability, resiliency, landfill mitigation, methane abatement, and all of these things both align commercially with the plans of a business, but also what the international and domestic communities have set forth as their decarbonization and goals, both coming up in 2035 and longer goals in 2050. And so by partnering with the right companies, our technology can, do 30 million tons of carbon sequestration annually once we get to volume. And doing so, we're also helping feed the energy demand while avoiding the cost and the expense and the hassle of waste management operations. And so I think we've got this magical moment where, are you pro environment? Yes. Are you pro business? Yes. And that is what we have to work towards. And that's where I would want both, all sides of the equation to come together and say humanity moves in one direction, that's forward. But we're always looking back and asking, like, where are we at compared to yesterday? And to me, where we're heading towards is, sort of fast, consolidated, streamlined waste management processes that look for a first tilt towards a circular solution before they go to a linear one. And I'm really excited that the upcoming generation has a lot of passion around climate impact, because what we can do with this technology is bridge a generation.
That's incredible. Miles, can you back up a little bit? And for those who may be not familiar with the terminologies, define circular economies for us, if you would.
So when you throw something into the trash can and the trash man picks it up and he takes it to a landfill and he buries it, that's what you would consider somewhat of a linear economy. We do not return the materials from the source at which they were extracted. In a different image, what I would say is, say we go harvest, 10 hectares of forest, a tree farm, if you will. Well, those trees are full of carbon that got extracted through a combination of pulling it from the air, but also pulling it from the soil. When we cut that tree down, we go build houses with them primarily. and that's important. We all want housing, affordable housing, so more cutting is going to be required. Um, but when we also sequester the carbon from that cut and we sequester it from the sawmill where we're pulling 30 to 40% back of that total mass, and then we go and reinsert it back into the very soil that the trees were grown from, then now you've circulated back any of the waste materials that would traditionally just get burned up or put into a landfill. And so the idea that this system supports that system, and then final system goes and supports the beginning of the cycle again. Well, now you've kind of got that natural carbon cycle. And for those that are kind of familiar with carbon cycles, it's no different than many of the sort of like rain cycles, like water gets evaporated, turns into a cloud, and rains. What would be devastating is if the rain never returned from where they evaporated from, and then you would end up with deserts, and then you'd run out of the source at which the evaporation came from, so you end up with a dead planet. So you want to figure out that circular aspect of economics that matches the natural circular ecosystems at which those economics are dabbling in, if you will, or disrupting.
And also, thank you for that. And also, now you brought up carbon cycles, could you quickly summarize a carbon cycle, give us a visual on
Sure.
parallel to
So
that?
carbon exists in everything that's organic, and everything that's organic generally decomposes. So the idea that we have carbon into our soil is really just a bunch of stuff that was alive and has now died, and it's decomposed, and it breaks down over time into this, different molecular chains. And so carbon being one of them, and you've got all your nutrients and everything, and that then creates where you get like lots of worms and lots of bugs, and that's a really healthy soil, right? But when you grow farming and you till over and over again, what you're doing is you're completely disrupting that ecosystem that lives in the 6 inches underneath the soil. And that is more vibrant and, for geeks like me, more exciting than the 20 miles above the soil, right? There's just more life. There's way more life 6 inches under the surface than there is on the top of the surface of the earth. So when we farm things aggressively, we're stripping carbon out of that system. And then we're rapidly growing these plants, and we're cutting them down, and then we're relocating them to somewhere else. So you're effectively removing you're taking withdrawals from the soil. You're not necessarily putting it back in, as opposed to like an old growth forest where trees fall, their limbs fall, it hits the ground, rain falls on it, it decomposes, and that sort of circle happens naturally. On a larger scale, you've got forest fires. They burn up a ton of carbon, put it into the atmosphere. You've got volcanic ash that puts it in the atmosphere. And so we rely on plants to pull it down and to absorb it into their leaves. The more that we develop the planet, the fewer there are areas that are able to mass capture carbon. So we end up with larger and larger, measurements of carbon. I think we've kind of increased by 25% over the last 50 years ago in the amount of saturated CO2 in the atmosphere. And is that a problem? Well, it's a problem in certain circumstances. It's not a problem in others. But more importantly, it's recognizing how we are finding a harmonious approach to the natural life cycle, which really depends on returning carbon from the source at which it was extracted.
Thank you for all the depth there. Any other terminologies that you and I may be familiar with that you've mentioned that you want to elaborate on, that you've brought up during our conversation today? Just to be clear on definitions.
Yeah, I think what people have to understand is that when you're building hardware today, there's kind of dumb hardware and there's smart hardware. What I mean by that is that dumb hardware is where you have to kind of have a human operator that's moving the dials, right? Smart hardware has got degrees of intelligence depending on how much investment you want to put into a product. But what we look for is something that is constantly improving itself. So in the world of tomorrow, that we're building today, machines don't break down without telling you why. And they don't break down, hopefully, in order to tell you why. They'll tell you ahead of time, hey, we're starting to, the auger system is starting to wane a little bit. There's a possible, binding in the system. Can you check it out? So as we build these type of systems, controlling the effects of pyrolysis, controlling the flow of natural, like synthesized natural gas, the ability to use instrumentation to measure in real time the amount of methane and carbon that you've abated is becoming commonplace. And one thing I know about a lot of the wood industry is that, that it's difficult to change. It's difficult to mature into the next generation of technology. It's expensive and long time. It's cumbersome, but that is what I've set out to be, is to make change management as easy as possible. Literally, let me back in two skidded containerized systems, give me a little bit of square footage, and I can solve this problem. My technology will largely solve this problem itself, and it has very few human hands on the solution. And that's good for kind of accelerating the adoption of the technology.
I love it. Miles, well, my personal mission is to improve the lives of the people in the wood industry globally. And that's really why I wanted you to come on the podcast and share with us, maybe from more of an educational perspective. And thank you for doing exactly that.
Yeah.
How the technology you're building and what it does and what it can do. Can you answer specifically and simply, how does your technology improve people's lives in the wood industry globally?
Well,
And
it's a catalyst. Right now we've got still a lot of legacy systems that are being used, and they work just fine. But the world is turning circular, and in order to provide an economic incentive for people to move towards a more circular way, I've built a technology that gives them every dollar that they were spending to get rid of something, they're now gaining a dollar mindset. And it takes a little bit of time and it takes some effort to get it all working in their favor. But this is a catalytic moment. And you want to, I speak to all the people that are working every day in these fields, or this industry, and the different facets of the industry. And I have to ask yourselves this every time. Going forward, when you see a pile of waste, wood, that you're going to burn, ask yourself, do you realize that you're burning a pile of potential profits for your company? And you're also not returning a good to the public that they're willing to pay for, because those two go hand in hand. There's the subsidy of carbon credits, and we do calculate those precisely for our clients. But there's also the real tangible product that comes out of this that has a growing demand. So not only does it improve your economic, it also aligns with many people's sentiments. And that is, well, of course, I won't throw something away if it doesn't need to be thrown away. But I have no other viable solution for this. So I'm forced to do it this way. You're no longer forced. It's now a choice.
Miles, that's pretty exciting. So, like over the last several weeks, I visited several sawmills, and one gave me a really cool behind the scenes tour where I was able to go and see, for example, the way that lumber is dried in the kilns is on a steam. There's a boiler that generates steam. Steam goes into the kilns. Steam never leaves the piping and all of the technology there, but the heat from the steam is used to dry the lumber. Steam is inside of basically a closed loop circle, and it's powered by burning with in the boiler. What happens is there's like the sawdust and the bark in this case goes through a hog and then goes to the boiler. The boiler obviously burns those, and so that exists. But what I understood is that there's so much more generated than is being consumed in that system, because that one was maybe well, it's more than this one is better than typical. This one's such a closed loop and well sealed system that the steam never leaves, and so therefore they don't need that much energy to power it. Therefore, a lot of the residuals are available, and they sell them somewhere else. So, practically speaking, if people wanted to understand how this technology could be in their factory, or is there practically a way that they can get a hold of you? Is there any pricing that you share now, or if it's early yet, how can they find you and
Yeah.
get connected with you to learn more about what could people practically do in their operations?
Yeah. So a lot of information on our website and how to get a hold of us, www.locoal.com. And that's a play on words for low carbon. So www.locoal.com. And if you want to email us directly, hello, HELLO, at local.com. And by reaching out to hello at local.com, you can introduce yourself. We've got, it's a small but mighty team of 10 of us, in which 3 of us are constantly doing business development. We're taking orders now, get you into the manufacturing pipeline. Pricing is proprietary on a platform like this, but it's extremely competitive. I will tell everyone that their return multiple is quite better, simply because we're unlocking the full potential of the value, not just partial potential. It's a total solution for your biomass, and the entire machine is geared towards maximizing the economic factors of that conversion. So you're looking at less than 3 years to get a full return on a system that we warranty for 10 years on the welds, but we expect it to last quite longer than that. This is a 20-year system.
Incredible. Miles, thanks again for, talking to me and having this conversation across your technology, providing some education here. If you could leave the audience of the wood world with some closing thoughts and your encouragement, call to action, what would that be?
Well, I would say that, born and raised in the wood world, and I know that, despite market reverberations that happen all the time, we continue to build. We're continuing to build all over. My area in Texas is like the fastest growing in the country, and they just can't build houses fast enough. So the demand for this industry is not going away. But there's also a second demand that's happening, and that's somewhat driven by culture and somewhat driven by modern technology and economics. And that is become a zero waste community. Don't ever see any of the byproducts of your work and labor be considered as waste. They're all alternatives, and there's people like me that are working to provide the tools so you can achieve that goal. So give us a call. And if there are also any other investor class, you can reach out to us too. We are a high growth technology company, so we're kind of always in, that mode, if you will.
I love it. Miles, well, thank you so much for coming on to the Wood World podcast. I hope this was, to the audience, helpful, beneficial, educational. Leave for Miles and myself your comments in the comment section below this video, and we'd love to connect with you, ask questions, give us your feedback on what you heard and what stood out to you. And with that, Miles, thank you so much, and we're gonna say goodbye here.
Thanks, everybody.